Okay, so this is Miss Montgomery trying my hand at a video again, and we're going to talk about 45, 45, 90 triangles. And I'm going to show you two reasons or two ways to understand why it's a 45, 45, 90 triangle. Okay, so you should be taking notes. Write that down, 45, 45, 90 triangle. Okay, we're going to start, so the first one is a demo. We're going to start with a square. What do we know about squares? Hopefully your brain is answering, oh, it has four 90-degree angles, right? And what else do we know about a square? All four sides are the same, right? That's what makes a square a square. Well, suppose we took that square and folded it into a triangle, because you know how much I love triangles. And I super duper love right triangles. Okay, so there's our triangle. So now what do we have? We have this angle right here. That's where the 90 comes from. Here is our two sides, and that makes it isosceles. Isosceles. And the 90-degree makes it right. So it's an isosceles right triangle. But what do we know about these two angles? Since it's an isosceles triangle, we know that these two angles have to be the same. We're going to call them theta. So that's new for you. Don't get freaked out. It's just a new symbol instead of using X all the time. So before we folded it into a triangle, they were 90 degrees. So what happens when we fold them? What's the triangle angle now? Hopefully your brain is saying, oh, it's 90 divided by 2, which is 45 degrees. Same thing down here. 90 divided by 2, which makes this 45 degrees. And that's why it's called a 45, 45, 90. Yes? Okay, option 2. Because I don't believe you believe me yet. So, what do we know about triangles and their angles? Yes, we know that they have to equal 180 degrees. So we're going to say 90 plus theta plus theta. 90 plus theta equals 180 degrees. And those words are getting in my way. Okay, so now we're going to do a little algebra 1. 90 plus 2 theta. I didn't do anything over here. Minus 90 minus 90. So now I have 90 equals 2 theta. And now I have to divide by 2. And theta equals 45 degrees. So that is the second way you know that this is a 45, 45, 90 triangle. I'm hoping you're putting this information in your notes. It is pretty key, helps you to remember what you're working with and what we're doing and why it's called a 45, 45, 90. Now, also, we know some things about a 45, 45, 90. We know that it's a right triangle, and suppose these two sides were the same. We're going to call them in like number. Then, what would this side be? Well, we have Pythagorean theorem, and we can check what that side is using Pythagorean theorem. So, because my space is kind of small, I'm going to erase that, but I hope you have that in your notes. And now we're going to do a squared plus b squared equals c squared. We're going to fill in the n for both the a and the b equals c squared. N squared plus n squared equals 2n squared equals c squared. But we don't want c squared, we want c. So we have to take the square root of both. Well, the square root of 2 stays the square root of 2 because it's not a perfect square. But the square root of n squared is n. And so c is equal to n square root of 2. If you need to pause the video, please pause the video and write down the things that you need to write down. So basically, what you have is if you have a triangle, which we already drew, so you don't have to redraw it, and the sides are in, then to get to this side, we are going to multiply by the square root of 2. And that makes this side n square root of 2. That's our first relationship. N square root of 2. And remember, n just means number. Okay? Remember, you can pause the video and catch up on your notes if I'm going too fast for you. Okay? Suppose I know this side, but I don't know this side. How do I get it? Well, I'm going to do the reverse. I'm going to divide by the square root of 2. Oh, that seems simple enough, Miss Montgomery. Well, there's a little bit of square rooting radicals that you have to remember. Please write yourself a note to self. You may not have a square root in the denominator. Okay? So where we have 3 divided by square root of 2, we're going to now do some math because we can't have that square root in the denominator.
Obadiah O'Neill, please report to the front of the school. Obadiah O'Neill, please report to the front of the school.
So whatever the square root is that's in the denominator, we're going to multiply by that. But because it's a fraction, what we do to the bottom, we must do to the top. Remember, in fractions, you multiply straight across. So we have 3 square root of 2 over what? Hopefully you are saying square root of 4. Oh, but wait, square root of 4 is a perfect square. So 3 square root of 2 over 2. So anytime you have a square root in the denominator, you're going to multiply top and bottom by that same square root, do the math and simplify and get whatever your answer is over here. So just to recap, if we have a right isosceles, which is a 45, 45, 90, and I know that these sides are n, to get to this side, I'm going to multiply by the square root of 2. So n square root of 2. And if I don't know my other sides, but I know this number, then I'm going to go back the other way, and I'm going to divide by the square root of 2. Remember your note to self. You cannot have a square root in the denominator. Hope that helps.